So what I'm going to do in this video is to go over a problem on projectile motion. So the problem is, Physics Man, a superhero from National Science Foundation, is flying at a speed of 60 meters per second when he drops a package of flat materials. The package drops a total vertical distance of 800 meters. Determine the time it takes for the package to reach the bottom and the horizontal distance that it travels. Okay, so as always, we are going to write down our givens and what we have been asked to find. So we have been asked to find the time that it will take the package to reach the ground and the total horizontal distance that the package will travel while it is still in air before it hits the ground. We have been given that the initial velocity is 60 meters per second. We know that the plane is flying at a height of 800 meters, and remember that the convention is negative for downwards, so I assumed that the distance is going to be in the downward direction, so that's going to be a negative. And our knowns are that the gravity is going to be negative 10 meters per second squared. So what do the equations look like? So here's my first equation, which is really part of the kinematic equations that we looked at in the previous unit. And this is the same equation, except that we are going to change the variables. Instead of plugging in x's, we're going to plug in y's, but they are both same equations. Now let's look at a diagram or a picture. So this is my plane, this is the package, and the package is going to drop to the ground, and we have to find the total the horizontal distance that it travels. So understand that the package is not going to fall straight down, but rather it's going to fall in a shape of parabola. So we'll have to find what this distance is, and we will also have to find the time that will it take for the package to reach the bottom. Okay, so first we need to find the component of time that it takes for the package to reach the bottom. So what do we know? Well, we know this equation, that delta y equals the initial velocity times time plus 1/2 at squared. Now, one important thing that you need to know is that if you want to find time in a projectile motion problem, you will always have to use the equation that deals with the vertical variables. So that's why we're going to use the first equation, and I'll show you why in just a second. So our equation to find time is going to be delta y equals VOT plus 1/2 at squared. Now remember that we don't have any initial velocity in the y direction, so this is going to cancel out, and we are just left with 1/2 at squared, right? We know that delta y is negative 800, which equals 1/2 a, which is negative 10 t squared. So we're going to solve for t, and I'm going to use my calculator. So what you do is you do negative 800 times 2 divided by negative 10 and take square root of 160, which gives you 12.65 seconds, which is a lot of time. So that is the time. So that's part A. Now part B asks me to find the horizontal distance that it travels. Since it's asking me for the horizontal distance, I will have to use the formula that deals with the horizontal components, and that formula is going to be the bottom one. Delta x equals the initial velocity times time plus 1/2 at squared. So let's write that down. We have delta x equals VOT plus 1/2 AT squared. Now, in this equation, 1/2 AT squared cancels out. And the reason is that we don't have any acceleration in the x direction. Remember that the horizontal and the vertical components are independent of each other in a projectile motion. So we don't need the value of a. I mean, it's going to be 0, so this cancels out. So that being said, we're left with delta x equals VOT. So we know that the initial velocity is 60 meters per second. 60 meters per second. And we just found the time. It's 12.65 seconds. So let's do the math. 60 times 12.65. That gives me 759 meters. And boom, that is my answer. So for solutions, my time is going to be 12.65 seconds, and the total horizontal distance is going to be 759 meters. I hope that helps.